Problem number 1. The particle moves along the x-axis so that its position at time t is greater than 0 is given by this function. Part A. Is particle x moving towards the left or towards the right at time t equals 1? Give a reason for your answer. The only thing we have to really focus on is the velocity, because the velocity gives me direction. Well, the velocity is going to come about the derivative function. Our justification cannot be that the velocity is positive. Our justification has to be that x prime is positive or x prime is negative. So what we're going to do is we're going to find x prime of t, which is 9t squared minus 18t, and we simply plug in 1. We get 9 minus 18, which equals negative 9. We notice it is negative, so therefore we will say the particle is moving to the left at t equals 1 because x prime of 1 is less than 0. That is it. You will get 1 point for having that x prime of 1 equals 9, and then 1 point for the justification. For part B, at what time is the particle farthest to the left? The fact that it is telling you the farthest to the left is an optimization problem. We're looking for an absolute minimum here. This is an open interval. It goes from 0 to infinity. So we want to minimize x of t. In order to minimize x of t, we have to find critical points, and that'll come about looking at the derivative, which we just found earlier was 9t squared minus 18t, and setting it equal to 0 and undefined. Undefined, not important in this case. From here we get t equals 0 and t equals 2. Luckily, because our domain said greater than 0, actually greater than or equal to 0, never mind. We will make a sign chart of x prime. We plug things in. We get negative and positive. So what do you notice? There is a minimum here. But our justification cannot simply be that the derivative changes from negative to positive. No, we have to explain every single point. So our justification will say something like this. Since x prime of t is less than 0 for the interval 0 to 2, and x prime of t is greater than 0 for the interval 2 to infinity, notice how based on the two intervals, if I look at them together, I've covered every single point on the graph. Actually we should say the particle will be farthest to the left at t equals 2. This one was worth 3 points. 1 point for taking the derivative set equal to 0. 1 point for having values of t correctly done. And then 1 point for having the justification. And if you missed any part of the justification, you don't get all the points. The sign chart does not get any points. The sign chart was simply there for you. Last, a particle y moves along the positive y-axis, and it's given by y of t equals 7t plus 3. What we're going to try to do is we're going to try to find how fast is the area that is created by this right triangle changing. So what are we looking for? We're looking for dA dt. What is area going to be? Area is going to be 1/2 x times y. Now, x and y are both variables in this case because they're both changing. Therefore, when I take the derivative, it's with respect to x. I'm going to take 1/2, and then comes the product rule. X prime y plus y prime x. This is looking specifically when t was equal to 1. So dA dt when t equals 1 is 1/2 x prime of 1 times y of 1 plus y prime of 1 times x of 1. Some of these values I already have. For example, x prime of 1 I found out in part A was -9. Y of 1, we can plug in 1 into the y equation. Y of t was 7t plus 3. So that would just be 10. Y prime of 1 would be the derivative of y, which would just be 7. Doesn't matter what x is. And x of 1, if you go back up to part A, whatever the formula was for x, I believe it was 3t cubed minus 9t squared plus 7. I'm just going to double check. Yep. This was x of t. Plug in 1, you get 13. Not 13, you get 1. If I simplify this, I get negative 41.5. The points here came mainly from having the correct derivative, evaluating it correctly, the answer, of course, and then we also gave you one more point if you actually started with the correct formula. So even if you didn't know anything, at least write down the formula for area. That's 4 points, totals up the whole problem to 9 points.